Hi everybody, Mr. Lee here. In this video, we're going to do a couple more examples of position versus time, velocity versus time, and acceleration versus time videos. Alright, let's get started. So, I'm going to first create a position versus time graph. Last time we did a position versus time graph where the object was accelerating in the positive direction. This time, let's change things up. Okay, I'll do this one in red. Let's take a look at this curve right there. All right, so let's remind ourselves a couple of things. One, the slope for a position versus time graph. Okay, the slope tells us the velocity, and in this case, we can see that this slope is negative. Okay, it's pointing the downward directions. Next, let's take a look at the curve itself. Okay, so if we take a look at the curve itself, as it's going from left to right, is it getting more and more vertical, or more horizontal? Or as I like to call it, is it getting more and more slopey, or is it getting more and more flat? Okay, so as we go from left to right, we notice that the rightward portion of this line, that's pretty flat right there. Okay, and if the slope is flat, that means it's not even a slope, right? The slope could be zero. It's not moving. So from there, we can see that this slope is getting more horizontal. Okay, so what does this mean for us in terms of acceleration and velocity? So if this slope is getting more and more horizontal, okay, let's compare the positions. So if I look here initially, right there, in this initial, we'll call that A, and we'll compare that to right here, we'll call that B. All right, so the velocity at A versus the velocity of B. We can see here that because it's more vertical, that means it's going faster compared to here where it's more flat. And if you have a flat slope for a position versus time graph, that means that the velocity is pretty small. So we can say that the velocity of A is greater than the velocity of B. So what this tells us is that this object is slowing down. Okay. All right. So here we have a couple of things. I'll make it a little bit cleaner. We have a negative velocity, okay, and we also have a acceleration. We got to figure that out, but the object is slowing down. So if you remember, the only way that a negative velocity can slow down is if the acceleration is, you tell me. That's right, positive. If we have a positive acceleration. Okay, so let's go to the next graph. Let's do a velocity versus time graph. We'll do it over here. So we have a velocity versus time graph right here. And what we have to do is we have to take this information that we just discovered over here, and we gotta translate it to this velocity versus time graph. All right, so we have a negative velocity, and it is slowing down. So this right here, this idea of slowing down is very important. When you slow down, eventually, well, according to this graph, if you continually slow down, eventually you're going to reach to a point where you are completely stopped. Okay, so you're going to slow down until you stopped, and this is where your velocity is 0 meters per second. Okay, so this is after time has progressed. And so I'm going to do that. I'm going to represent that with this red dot here. So as time progresses, this object will have slowed down. Okay, it's going to come to pretty much a stop. It's going to approach there. We have a negative velocity, so I'm going to start in the negative y region right here, and we know that there is a constant positive acceleration. Okay, so before I draw in the line, let's do a quick reminder. Remind yourself that the slope for a velocity versus time graph, the slope is your acceleration. So we need a positive slope. We need a positive slope. So I'm going to start down here. I'm going to end up there with a positive slope. Okay, and it's important to know that our velocity will be constant. It's constant and it's positive like that. Look at that. It's pretty nice. All right. So we met all the criteria so far. All right. Now, in order to come up with the third graph, let's see if I could shift this over. Okay. The third graph will be the acceleration versus time graph. So we have the acceleration versus time graph. Okay. Let's review what we know. We know that there is a positive acceleration and this is a constant slope. Okay, so it'll constantly be positive. Now we can actually find the slope if we had numbers, but because we don't, we're just going to sketch what this is going to look like. Okay, it will be a positive slope. So our acceleration will be positive, and it does not change because that slope is constant. So our acceleration versus time graph will look something like that. Okay, now let's do something slightly different. What about a velocity time graph that looks something like this? I'll do this in red. Whoa. All right. So let's use our critical thinking caps here. Okay, let's break this down. I'm going to call these two regions region A. Right there. That's a very important part. I'm going to call that B. And right here, this will be called region C. All right. So we have A, B, and C. Now, that point right there is very, very important because the AP exam, it likes to ask about that point in particular a lot because a lot of students get that one confused. So I'm going to break this part up. So region A, we know that in this region, the velocity is negative. Here we have a slope, and this slope, because it's going upwards, the slope is positive. Okay, so what this tells us is that the object is slowing down. Okay, this object is slowing down, and we know that because at point B, right there, for a brief moment, this velocity is 0 meters per second. So what this tells us is that the object has stopped. Okay, stopped moving for a brief moment. Here we see that the velocity, because we're in the positive region of this graph. Okay, that's the positive region. The velocity is positive. We have a positive slope, and the acceleration therefore is positive, and therefore this object is speeding up. So what does this tell us? This tells us that we have an object that it was moving, let's say, to the left, right? It was moving to the left, but it was slowing down. Okay, it was slowing down until it eventually comes to a stop, and then it starts to speed up towards the right. Okay, I'll say this again. We have an object down here. It started off by moving towards the negative direction, but it was slowing down. Eventually, it got to a point where the object stops. And then after that brief moment of pause, it'll continue in the positive direction. So you go to the left, you stop, and you turn around. Okay, it's kind of like taking a U-turn. So let's translate this velocity time graph to a position time graph. All right. So here we have negative velocity. So with a negative velocity, that means for a position versus time graph, that means we have a negative slope. Okay, so we have a negative slope. So let's assume that we're starting at position 0. We have a negative slope, and that negative slope is going to reach it's going to be very vertical in the beginning, but eventually it's going to flatten out. Okay, and then from there, we're going to have a positive slope. And it's going to be towards the positive velocity, but it's going to also be curved. All right. So it looks like it's moving pretty fast. So I'm going to have a very steep slope until I come to a stop. So this is a steep slope until I come to a stop. Okay, so notice right there, I'm going to call this B. We know that this is B because the slope here is flat, And a flat slope means that your velocity is 0. Okay, and then here, so let's break this down. This is a negative velocity because it's going downwards. Okay, and we know this is positive acceleration because it's going more and more and more towards a flat zone. That means it's slowing down. And at B, it's stopped. And so right here is a very flat zone. I'm going to extend that out a little bit. There's a flat zone. And then it's going to speed up. Okay, so if it's speeding up, that means it starts off flat, but then it gets more and more vertical. So we get something like that. Okay, isn't that cool? All right. And the next one we're going to do is a acceleration versus time graph. All right. Now we can see here that the acceleration was positive. Okay. Now here, even though we didn't say it, we can say that right now. Remember, even if an object has stopped, it can still have an acceleration. So the acceleration is positive, and here the acceleration is positive. And we know that this is the same acceleration throughout because the slope of this graph is constant. And the slope for a velocity versus time graph is the acceleration. So we can just draw it like this. Okay, so whatever this slope might have been. All right, let's do one more. See. All right. Let's do one more. Let's do another. Let's do another velocity versus time graph. Okay. All right. So here we have another velocity versus time graph. This time, let's do. Let's do something very unique. Let's do something like this. Ooh. All right. So I'm going to call this point B. I'm going to call this point A. I'm going to call this point C. Okay. So let's break this down. Here we have an object that is, so from A to B, we have an object that is, we have an increase in velocity. So the object is speeding up. The velocity is constantly positive, and the slope here is positive. So the acceleration is positive. Okay. At point B, things change, right? So from B to C, we see that the object's velocity, it goes from this high value and it goes towards 0. So we can say that this object, because it's going towards 0, the object is slowing down. Because this velocity is still the positive region, we can say the object still has a positive velocity. But because it's slowing down and we have a positive velocity, we can say that the object has a negative acceleration, and we see that in the slope. So if I were to translate this to acceleration versus time graph, we will get something like this. Okay, we will have something with a positive acceleration. So this is A, right? And then at time interval B, things change. We jump to a negative acceleration. Isn't that cool? Now, this is really cool because this can show us exactly what we can do. Remember, slope for acceleration versus time graph, we don't care, but the area under the curve for acceleration versus time graph, that tells us our delta V, okay, or the change of velocity. So if I wanted to find the change in velocity or the area under the curve, I want to show you that because it's a good reminder. Remember, this line is our curve, and we always go from the curve towards the 0. Okay, and so we would find the area of that little rectangle right there, and that will tell us the change in velocity for that time zone. And if we wanted to find the area of the curve for this portion C, we will go from the curve, which is down here, this line, and we will go towards the 0, which is whatever this rectangle would be in terms of the area. Okay, that will give us our area under the curve. All right, now for the final one, let's do the position versus time. This is where things get a little bit tricky, so bear with me right now. All right, so we have a position versus time graph. Okay, so in the beginning, we see that the object speeds up. Okay, it speeds up and it has a positive velocity. All right, so the object is speeding up with a positive velocity. So that means that it's the velocity starts off flat, because right here the velocity is 0. Okay, the curve starts off flat. Let me use a different color. The velocity starts off flat, but then it ends up at B. Okay, so let's say that this is B. It's pretty vertical, so we get something like that. All right, and then at B we have now a negative slope. Okay, so this is positive because it's going upwards, but after point B towards C, it has a negative slope, so the line is going to be going downwards, but it's going to approach velocity. Remember, right here, this velocity is 0, so it's going to be approaching a flattened out zone, so we get something that looks like this. I'll do this in a different color to help us see. I'll do this in blue. Wow, isn't that nice? So we see that as it approaches C, the slope is pretty flat, and we see that here because it's approaching velocity 0. But in the beginning, right here, the velocity is pretty vertical, so that means it's still going pretty fast, but it's going in the opposite direction. Okay, it's going towards the, let's see, it's going towards the negative direction because that's a negative slope. All right, now those are just 3 examples. With physics, these motion graphs can be used to describe like any object, and trust me when I tell you, it just takes a lot of practice. So hopefully I've gone over all of the basics and all the different mental checkpoints that you have to make in order to make sure you know how to read these graphs, go from one graph to another, and all the different information that these graphs can tell you. I'll see you next time. Bye-bye.